Buy-Sell Strategy Using Dynamic Programming by Professor Sayed Jafar Sajjadi. In this video, we show how a dealer faces different investment decisions when the buy and sell orders are different over a 5-day period. Consider a dealer who owns a commodity at the beginning of a 5-day period and plans to make money through buy and sell strategies at the beginning of each single day. The buy and sell prices for each period is shown in this table. At the beginning of each day, our storage could be 0 or 1 unit. When we have 1 unit, there are 3 options on our hands. At the beginning of each period, if we have 1 unit, we have 3 actions to do. 1. Do not do anything and keep this unit for the next day. We pay $1 for holding. Second, sell in the morning and buy at the end of the day. No holding cost. Third, sell and do not buy. Also, if we have nothing at the beginning of the period, we have 2 options. Fourth, do not buy anything. 5. Buy 1 unit according to market price. We assume we have 1 unit at the beginning of the day first and keep 1 unit at the end of the 5th day. Here, the state N attribute of the dynamic programming is defined as each single period. State I is defined as whether we have 0 or 1 unit. Action K is defined as 5 decision strategies that we just described. Revenue in each period N is obtained through buy-sell actions by considering the $1 inventory we pay. We solve this problem using backward strategy. When N equals 1, we are at the beginning of day 5, and the following 3 actions are possible. K equals 3 is not possible, since at the end of day 5 we must have 1 unit. K equals 4 is not possible, since we must buy 1. When I equals 1 and K equals 1, this means we have 1 unit at hand, but we do not do any transaction and only pay $1 holding. When I equals 1 and K equals 2, this means we sell at $12 and buy at $11 and pay no holding cost, so we gain plus $1. When I equals 0, we have nothing in hand at the beginning of day 5, and the only choice we have is K equals 5, which means we should buy, and therefore F1 equals negative 11. K1 equals 5. When N equals 2, we are at the beginning of day 4, and we can have all possible actions. Let's start with I equals 1 and K equals 1, which means we perform no action and pay $1 for holding. So in the beginning of day 5, we have 1 unit, and for N equals 1, I equals 1, we have F1 equals plus 1. Therefore, we have... Now start with I equals 1 and K equals 2. Which means we sell at $15 and buy at $14. So in the beginning of day 5, we have 1 unit. And for N equals 1, I equals 1, we have F1 equals plus 1. Therefore, we have... Now start with I equals 1 and K equals 2, which means we sell at $15 and buy at $14. So in the beginning of day 5, we have 1 unit, and for N equals 1, I equals 1, we have F1 equals plus 1. In addition, for I equals 0 and K equals 3, we sell at 15 plus F1 times negative 11. Now consider I equals 0 and K equals 4, which means we have nothing and we do not buy anything, so we pay nothing in this stage. But from n equals 1, f1 star, for I equals 0 is minus 11. So we have f1 star equals minus 11. Therefore we have, now consider I equals 0 and k equals 5, which means we have nothing, but we buy 1, so we pay negative 14 in this stage. But from n equals 1, f1 star for I equals 1 is plus 1. So we have f1 star equals negative 14 plus 1. Therefore we have the optimal solution for I equals 1 is equal to max minus 1 plus 1, 15 minus 14 plus 1, plus 15 minus 11 equals 4. And since 4 is obtained from k equals 2, so k2 star equals 3, and since minus 11 has been added from k1 star equals 5, so we have k1 star equals 5, the optimal solution for I equals 0 is equal to max 0 minus 11, negative 14 plus 1 equals negative 11. And since negative 11 is obtained from k equals 4, so k2 star equals 4, and since negative 11 has been added from k1 star equals 5, so we have k1 star equals 5. Again, suppose I equals 1 and k equals 1, which means we perform no buy-sell action, so we pay $1 holding, and from the previous stage, when I equals 1, f2 star equals 4. So we have f3 star equals negative 1 plus 4. For I equals 1 and k equals 2, we sell at $15 and buy $18. And from the previous stage, when I equals 1, f2 star equals 4. So we have f3 star equals 15 minus 18 plus 4 equals plus 1. For I equals 1 and k equals 3, we sell at $15 but do not buy back. And from the previous stage, when I equals 0, f2 star equals negative 11. So we have f3 star equals 15 minus 18 plus 4 equals plus 1. For I equals 0 and k equals 4, we do not do anything. And from the previous stage, when I equals 0, f2 star equals negative 11. So we have f3 star equals 0 minus 11 equals negative 11. Also, for I equals 0 and k equals 5, we pay negative 18, since we only buy. And from stage 2, we have f2 star equals 4. So the cost for k equals 5 is negative 18 plus 4. For I equals 1 and k equals 1, we do not do anything and pay holding cost of $1. And from the previous stage, when I equals 1, f3 star equals plus 4. So we have f4 star equals minus 1 plus 4 equals plus 3. Also, for I equals 1 and k equals 2, we buy and sell at 13, so we do not make anything from stage 3. We have f3 equals 4. So the cost for k equals 2 is 13 minus 13 plus 4. Finally, for k equals 3, we sell at 13. So we have f4 equals 13 minus 11. For I equals 0 and k equals 4, we do not do anything and pay nothing. And from the previous stage, when I equals 0, f3 star equals negative 11. So we have f4 star equals 0 minus 11 equals negative 11. Also, For I equals 0 and k equals 5, we buy 13. And from stage 3, we have f 3 star equals 4. So the cost for k equals 5 is negative 13 plus 4. For n equals 5, we're at the beginning of the buy-sell action. We have 1 unit at hand, so we only consider k equals 1, 2, 3. For k equals 1, we pay only $1 for holding. And from the previous stage, we have negative 1 plus 4. For k equals 2, we sell at 11 and buy at 10. So we have plus 1 plus 4. And finally, for k equals 3, we sell at 11, and from the previous stage, we get minus 9. We hope this clip is useful for you and enjoy the topic. This complimentary product is brought to you by Growing Science publishing firm.